The concept of driverless tractors and farm machinery has been around for a while, but to many, it is just that, a concept. Just the thought of it working in a field in just any part of the world, let alone in Australia, still seems a little beyond reach, doesn't it? But what if I tell you that seeing this technology on your farm is a whole lot closer than you think? This is Jay Katupitia. He has been a lecturer and researcher at the University of New South Wales School of Mechanical and Manufacturing Engineering for over 20 years. When he's not in the lecturing theatre, he can be found in the workshop toiling away on his biggest project to date, a robotic tractor and seating system which requires no one in the driver's seat to operate. It was about 5 years ago that Jay and his team of researchers set to work on the driverless agricultural planting system called the Smart Cedar, with aims of increasing on-farm efficiency with less resources. While big guns like John Deere and Case IH have begun developing their own autonomous farming systems, none of them are quite like what Jay and his team have created. For starters, the implement, not the tractor, is the primary focus of the project. The team have equipped not only the tractor but the Cedar with an array of sensors that allow it to drive, steer and propel itself without much help from the tractor. By using smaller machines too, the team hopes to help farmers reduce soil compaction on their property.
Our approach is that you have the power where it is needed. The traditional approach is to concentrate power in the tractor, which is the main prime mover, and therefore making it enormously large, and therefore it causes a lot of ground compaction and you lose a lot of land to ground compaction. If you make the tractor very small, then the ground compaction disappears, but at the same time you still have to face the question of where is the power coming from. So you put the power at the back, but the advantage there is that although that is still going to be the same prime mover, it has been supported by many wheels of the implement. So that way the load is actually distributed right across the land, and as a result the individual compaction is smaller.
As you can imagine, the technologies and processes involved in making the unit work is nothing short of complex. A web of sensors, actuators, motors and GPS receivers communicate with each other to operate the self-driving machine.
You can drive around the paddock and do the surveying by the tractor itself. You can also drive around the obstacles, you can drive around speed zones, so you can drive around anything and survey them using the tractor itself, and all these things are fed into a database. And then through some simple interface, a farmer can easily create a path, and this path will have all the run lines laid out in the field. For that you need a lot of sensors. Primarily we use GPS. Positions are sensed using the GPS receivers, which are the two disc-looking things at the two sides. And right in the middle is an antenna to receive GPS corrections from a base station. We have a base station up on the roof here. So we start the control panel, and this is where all the controls are. And as you can see, there are many programs that you can run. Each of these buttons correspond to a certain program. You can also choose a path to follow, but today we follow the demo path. So once all these programs are running, then they start communicating with all the devices, all the sensors that are around here. Then they command the steering. Steering is actually driven by a motor that is attached to the steering, but the propulsion is already interfaced to the built-in computer of the tractor. The signals from the computer is directly wired to the wheel driving mechanism, so it drives the wheel. When the tractor pulls, then there's a tension that develops here, and there's a force sensor here, and that sensor feels the force that is being generated. So that signal is then picked up by the computer, and then the computer drives the wheels. You can see there are motors attached to each of these wheels, so these wheels are actually driven. So that's a hydraulic motor. These wheels can be steered, so steering commands are also coming from the same computer. As you can see, there's a cylinder here, and that cylinder is actuating the steering, so these wheels can steer left and right. And in addition to that, when the right time comes, the plows has to be put down, and that is done by another actuator that is also commanded based on the GPS location. So when you're at the right location, it commands that hydraulic cylinder, which puts the implements down, and then it keeps going. And when the time is right, the same actuator is again actuated and the implement is taken up. And that's the time it goes into the headland operation, which turns around and comes back to another run again. And coming to the front of the tractor, then we have a laser sensor which can sense anything that is in its way up to 20 meters to 20 to 30 meters in front of you through an angle of 270 degrees. So this is currently programmed to look at 90 degrees in front of the machine, and anything within 5 meters of it will signal the tractor to stop.
While the system has been primarily designed for seeding, the idea is for it to be applied across a range of farming jobs in the future. The system is now ready for the market. Just late last year, the university and startup technology company Orotron has formed a partnership to bring the technology to the public, which means you can have this working on your farm in no time at all. Since the partnership, Orotron has developed a driverless system to suit spraying operations. The company has incorporated several custom hardware and software to the system that makes it easy for farmers to operate. This includes a path planning and machine tracking user interface, as well as a real-time tractor monitoring software that shows the user all vital machine functions real-time and remotely on their PC or mobile device. Orotron's hardware also comprises a laser collision avoidance system and weather station that interacts with the software to control the autonomous unit. Most recently, Orotron has signed a deal with spraying equipment expert Croplands to distribute the technology in Australia and New Zealand. The company is confident the technology will be launched and ready for purchase by the first quarter of 2016. For the detailed feature on the Smart Cedar and the driverless technology, don't forget to pick up the next issue of Farms and Farm Machinery magazine.